next time I see you, we're going to do homework check over 11.1 and 11.2. Pretty sure y'all got 11.1 done because we had class time. It was just those 4 graphs. 11.2, I'm thinking you'll probably have class time to do it as well because I kind of think this will go quick. But we'll see. And then we're also going to take a check for understanding at the beginning of class next time. That one is a little bit longer than our normal check for understanding because it kind of has a couple different types of problems on it. But our lesson, again, after that should be pretty short. So I think, honestly, most of these lessons are fairly short. And then, yeah, we've just got your tests coming up on the 5th. So be aware, everything's on the calendar. That's the plan. Taking a break from transformations. I don't want you to forget all of that stuff about like the points and the asymptotes and the domain and range, all of that. You need to make sure you are still familiar with that because, again, it's your own test topic over transformations. And we really won't do much transformations in the next couple of lessons. That's kind of a standalone thing. We'll talk about the graphs a little bit more today. If you can see on page 5, you can see them there. But yeah, just make sure you remember that for your test. I was looking at the review, though, and there's like 4 or 5 graphs on there. So you should be able to review it before. And then today's lesson will also be its own test topic over converting forms and finding inverses. And again, it's not mathematically complicated. Like we're not really even doing any sort of calculation or anything. This is more just kind of understanding and seeing the relationship between the two types of functions. So all of this unit is going to build and help you be able to end up solving in Unit 12, because that'll be the last thing we really emphasize before the school year's over and y'all are ready to be little pre-calculus people. But one thing I do kind of want to mention, because, and I know I said this last time, you've seen exponential functions before. Those are when x is your exponent, all those things. We've seen graphs. Y'all have done exponential calculations in Algebra 1. Again, you may not believe me, but you have. But logs are kind of a new thing, and they're a little bit weird. They're not something that you can necessarily do in your head. Most of the time, actually majority of the time, you do need a calculator. So in that final unit, you will have calculator, at least part, if not the whole thing. I don't know. We haven't planned it yet. But I just kind of want to give you an idea as to like what you're doing. And we're really going to explore the relationship between the two. But I want you to know like why we need a log. So the first thing is taking a log of something is just like, you can take the square root of a number, or you can take a cubed root, or you can raise something to a power. Those are just all like types of operations that you can perform on numbers. And a log is the same way. But what's going to end up happening is I'm going to give you, and you don't have to write this down. I'm just going to write on my paper. But I'm going to give you something like 2 to the x plus 5 minus 7 equals 15. And I'm going to tell you to solve for x. Now, we've solved linear functions. We've solved systems of linear functions. We've solved quadratics. You know all the tools that you need to do that. But what's different about these types of functions is where is your x? And the exponent. So if you want to solve for x and get that guy by himself, you need to take a log. Okay, and this is like Unit 12, so we're not really doing this for a few weeks, but I just kind of want you to know like why we need to know about these functions and how they work, and it's so that you are actually able to, and I'm not going to be here to teach this to you, so I'm kind of telling you now. If you think about like levels, an exponent's kind of up here, and we want our final answer, we want x down here. We want to know like x equals what, all by itself. And so to kind of take x out of the exponent, that's where a log will come in. So this is where we're going with it. And again, the instruction that we're doing today especially, and then the next few classes as well, is going to be pretty foundational to be able to solve it when we get to actual equations there. So that's how it works. That's why it matters. And just if you were curious or if you really care, there's a little bit of an explanation between that. But for now, we know that exponentials and logs are inverses of each other. And I talked about this. I think I showed this graph last class as well. Let me get some highlighters here. And we transformed all of these. But so the first one, I'll do exponential first. Your exponential graph is this one right here. And we talked about the parent function and our parent function points there. In Algebra 1, when I talk about this, I always write exponential like this. So they remember that x is the exponent, and that's how you can tell it's an exponential. I think that's kind of cute. But you'll have a base. It's raised to the power of x. I do want to write in, what kind of asymptote do you have with an exponential? That's a horizontal, okay? And it will be, in this case, it's y equals 0. So that would be right here, okay? With your exponential graph. But the domain of an exponential is all real numbers because your exponent can be anything. Your range is restricted based off of that horizontal asymptote. And you need to be able to identify that, graph that, all the things we did last class. And again, keep that straight because these are kind of tricky. What are your points? What would you use if you have any base to the x? This is good review from last class. 0, 1, and 2 would be the x values that you would use because those are like reasonable exponents that aren't going to give you too big of numbers that won't fit on your graph, or you don't have to deal with negative exponents. Do you remember what the y values would be? 1b and b squared. And again, you can figure that out. If you know your inputs are 0, 1, 2, you can figure out b to the 0 is got to be 1. B to the 1 has got to be B. B to the 2 has got to be 2. If you forget, you can go backwards and do that. In log land, you can't really do that. But what do we know about logs? They're the inverse. So what does that mean? Everything does what? Everything flips. So here's your log graph. And again, graphically, you'll see they're a reflection over the line y equals x, which this is the line y equals x. So they're flipped over like that. They are your boomerang shape there. Again, it's obvious that it's a log because what word is going to be in the equation? Log. Okay, there shouldn't be any confusion. You'll be able to see it there. And again, you read this, log base b of x. You'll have a base. That base is important in determining your points. The domain is what's restricted in logs because what kind of asymptote do you have? You have a vertical asymptote. And so that's written as x equals. And again, if you know it's x equals, that has to restrict your domain. And so you have a vertical asymptote. And again, with the parent function, it's at 0. And then there's arrows on these graphs as well. And then your log points, I would know these. Honestly, this would be what I'm writing at the top of my page when I get my transformations test. With logs, let's see if I can fit this over here. Log base b of x. Where does the 0, 1, 2 go? On the y's, it flips. 0, 1, 2, and then your x's are 1b, b squared. So it's just the opposite, okay? So don't think of it as you have to memorize two separate things. Know the exponential, know log is going to flip. So that's kind of a review from last class. And then again, know what all your A, B, C, and D does, all that transformation stuff there. But what we're going to focus on today is converting between the two forms. That's the first focus, okay? And again, it's pretty easy. There's a little trick for you. And then we're going to calculate inverse equations as well, which is pretty similar stuff. So it'll be a little bit repetitive. But before we do that, I think I mentioned this at the end of class because on that problem number 4, in your homework packet, do you remember someone pointed out that there was not a written base on that last problem on number 4? I told y'all to write base 10. So there's two special logs, and it's the common log, which is base 10, and then the natural log function, which is base e. So again, if you see, this is how you would see it. You would just see it log x. If there is not a little subscript number, then it is implied to be base 10. And I know y'all guessed like 1 or 0 or something. You're not going to have a base 1 or 0 with an exponential or a log ever. But it is implied to be base 10. And that's just, I don't know, this is way before I was born. That's kind of what they went with. And so just know if that's not there, you can write it in. Honestly, I normally do write it in. Like if I'm using that, I'll write it to the side because it's important to know what your base is. But If it just says log, it's implied to be base 10. It's your default base. As far as in the calculator, we're not going to use calculators for a while, but there is a log button, and that is log base 10. There's a way to actually type it and get your, change the number, but y'all will go over that when I'm gone. And then the other one is the natural log function, which is base E. Have y'all learned about the number E yet? Did y'all know there is a number E? You know that? It's kind of like pi. Y'all know the number pi? Yes. What's the number pi? 3.14, something else irrational. I don't know. I never memorized all that. But there is a base E, and when you get to Unit 12, there's some of the formulas and the application problems have to deal with base E. I'll go ahead and show you your calculator now so you can see. So first of all, here is the log button right here. So if you press this button and take the log of something, this is going to always assume to be log base 10. So I can take like log base 10 of 5. And again, you get a lot of decimals with these, so cool. And then there is a natural log button right below it. This is the one I'm talking about next. That is base E. And it's pronounced natural log. So if you see this, and it's kind of weird because it's natural log, but it goes LN. Yeah, I don't know why. Again, this is older than me. I didn't make it up. But that implies that the base is E. Now, E is a number, okay? And it is on your calculator. We aren't going to do too much with, well, again, we're not going to do calculating here. You are going to see this, and I expect you to know that it's base E, but you're not actually going to be, like, calculating anything here. But just so you can see, there is the E button on your calculator. It's the lowercase e on the diagonal key. And E is an irrational number similar to pi, and it's about 2.71828. So it's an approximation. You won't need to deal with this specific number itself, calculation-wise, until Unit 12. But what I do need you to know is anytime you see natural log, it's kind of understood that there's a base E. And some people will actually, like, write that in to help them. Or, like, with this, they would, like, write log base 10 of X, and that's fine as well, if you need to do that to help you. But for simplification purposes, it's more simplified to just do natural log or just do log, depending on what your base is. So be aware of that, because that is going to come up today when we do converting and finding inverses, because you've got to know what your base is. And so sometimes we'll give you these to see, like, do you know what your base is, if it wasn't a different number than that. But so that's important there as well. I don't know if there's anything else I want to say about that. Okay, let's talk about how to convert, because this is the first thing that we need to know how to do, is convert between forms. Now, there's a diagram there, but honestly, this kind of like stresses me out a little bit. It's great. Don't scratch it off or just leave it there, but I'm going to just write to the side. So here's what we got. Log base B of A. I'll use their same lingo here. Okay, and I want you to make sure that you know the vocab. This little subscript thing is your base, and we talked about this last time. Your base is typically a number, but it can be a variable, it can be an expression, it can be whatever. But it is written lower, and I'm going to be kind of picky about that. When y'all do your conversions here, and I'll talk about it on the next page, I really want to see that it's like log is here, and then your base is a little bit lower. And then what you're taking your log base whatever of is called your argument. You need to know that word, because I'm going to be talking about that a lot, okay? Typically, I put the argument in parentheses, although it doesn't have to be. That's usually going to be kind of the same level as your word log. So it's like log, and then the base is down a little bit, and then the argument is kind of in line with the word log. Don't make it look like your argument is like floating up like an exponent, okay? And you'll see what I mean on the next page. And I know it's picky, but it just kind of drives me crazy when people start blurring stuff and I can't tell. But so this can be equal to something. Your argument can be a number, it can be a variable, it can be an expression, all the things, okay? So if I said, here you go, log base B of A is equal to X. And I wanted you to convert the form, and this is how these are connected and how you're eventually going to be able to evaluate some of them using mental math, and why you're going to be able to do some things in your head and some will require a calculator. So the relationship between the two is that if I wanted to go, this is log form, because what word is in there? Log. If I wanted to go from log to exponential form, here's what I would do. So this is our log form, and I want to switch to exponential. The key is that you always start at the base. What is the base of my log in this example? Base B. So that is going to be the base of my exponential as well. The base of the log will be the base of the exponential. But the way that these relate is I'm going to take the base of my log and I'm going to raise it to what my log is equal to. So x is what my log is equal to. That's going to become the exponent of my base. So you I think there's a teacher, they call it like a fish hook. So you swing it over. Base to this power is going to equal the argument. So another one of our teachers, she says a lot, your log is the exponent. And if you look at it, whatever your log is equal to, that is the exponent of the exponential. And that's kind of how they are related. This talks about how to read that. I already talked about that. Notice that the log expression represents the exponent. So whatever it's equal to becomes the exponent there. And so that's going to be what we're doing on the next page is we're just going log to exponential. We're going exponential to log. The key is knowing what the base is. It's not really hard to do. It's weird. Okay? But it's not mathematically challenging. We're not doing any sort of solving. We're just switching and then being done. You're going to have test questions like this. These test questions are going to be all right or all wrong. There is not room for partial credit because there is really nothing that you're doing other than switching. And if you can't switch one thing and you mess it up, then you don't know what you're doing. Okay? So flip over. There's a lot of examples here. I'm not going to do all of them. I might just pick a few to kind of show you some examples, and then I'll have you fill in the rest. But here's the key. You always want to start at, start at the base. Okay? The base of your exponential will be the base of your log and vice versa. Okay? Let me see which ones I want to do. We'll do the first three and then maybe a couple down here. Okay? So you'll catch on and you'll see it's pretty easy. So we're in exponential form at the beginning because number one, the instructions say convert from exponential to log. Also, you've got exponents. So that tells you it's exponential form. There's no word log here. Okay, if we're converting to log form, we are going to have the word log in our answer. And you start at the base. What is the base of 3 to the 5 equals 243? Log base 3. So look at how I'm writing it. Log 3 is a little bit lower. Now do your little fish hook thing or swing around or whatever you want to call it. Okay, log base 3 of, what will my argument be? 243, because that's on the other side of the equation. And what is this going to equal to? This is going to equal 5. And that is my conversion. That's my answer. Okay? So start at the base, swing around, swing it back. Okay? Number 2, I'm converting to a log. What is the base of my log? 6, because what's the base of my exponential? 6. What's my argument going to be? Log base 6 of 1/6 will equal -1. Okay? Now, before you start doing the rest of these, look here. If you type 3 to the 5th power in your calculator, what are you going to get? I mean, what does it say on your paper? 3 to the 5th is 243. So if you started with this, some logs can be done in your head. You're figuring out, what do I have to raise this base to end up at 243? That's how those are working. So if eventually you're going to get to evaluate, and you'll say okay, what power do I need to raise my base 3 to end up at 243? What power do I need to raise base 6 to end up at 1/6? That's kind of how that connection works. And so understanding, again, exponent ways is usually easier to go to do in your head versus log. Okay, let's look at 3 real quick here. This is e to the b equals 5. Okay, so there's kind of two ways you can think about it, but there's one way that I'd prefer you to do. If you want to just start with, okay, I know I'm switching to log form and then go from there, that's fine. So what is the base of my exponential on number 3? E. So it's going to be log base E. Okay, I'm just going to write this down, but this isn't going to be my final answer. So log base E of, what's my argument going to be? And what's it going to be equal to? B. So log base E of 5 is equal to B. But I'm not going to put a box around that yet because is log base E fully simplified? How do I want you to write that? Natural log, ln. So you can, I would write this as natural log, and you don't even have to have a base. You can just do natural log of 5, and that equals B. So if it helps you to start with log base E, by all means. But this is how I want you to finish the problem. Okay, to be fully simplified, I would want you to finish it there. And to be honest, we probably would take off points if you don't put natural log. Okay, because that's like how it's going to be in a multiple choice SAT type question. Let's look at 7 real quick. Number 7. Again, start with the log. What's the base of your exponential? On number 7, what's the base of your exponential? 10. So what's going to be the base of your log? 10. Again, write it there at the beginning, but am I going to keep it there in my final answer? No. Log base 10 of, what's the argument going to be? X plus 1. Put that in parentheses. And then what is that going to equal to? Negative 2x. Now, we're not solving anything. So even though it looks kind of ugly to like leave it, the only thing I want you to do before you box your final answer is do what? Just write log. Log of x plus 1 equals negative 2x. And then you're finished there. Okay? So we're not solving anything. We're just converting and stopping there. Anything else I need to do? I think y'all can do the rest. Yeah, y'all do the rest. And then we'll check them in a minute. Y'all can check up here. Again, you can have bases that are numbers. A lot of times they are plain numbers. But on like number 8 and 9, you can have bases that are expressions. I don't really know why I put parentheses around this base right here, but I'm just going to kind of go for it. You can. Typically, I only put parentheses around my argument. But again, I just kind of started writing it that way, and so I just went with it, and that's fine. But I think the arrows might help you at least while you're getting started to kind of know like how everything goes. But again, it's easy as long as you know you have to start at the base. Okay, the base of the exponential will be the base of the log. And then again, I don't want you to write log base 10, and I don't want you to write log base E. I want you to do the shorthand for that. Okay, any questions over that conversion? And we're not solving. I don't want you isolating x at all in any of these. Okay? Think we would do well on some test questions like that? No partial credit. Right or wrong. Okay? All right, now let's go the other way. So the other way, again, it's the same idea. You still kind of have the little swing around, fish hook around, whatever you want to call it. You still want to start at the base. That is the key. Oh my gosh, I did it again. Start at base. I can't spell. But you're going to an exponential form. So the base of the log will become your big base of your exponential, and then what it's equal to will be the exponent. So for this problem, okay, log base 9 of 9 is equal to 1, okay? How I know that and why that's true is because what's my base? So base of your log. 9 to the what power? First power is equal to 9. Is that true? 9 to the 1 is equal to 9? Yes. There's your conversion. You are finished. Okay? So again, when we kind of throw these numbers in here, you'll start to see like why those numbers are the way that they are. On number 11, what is your base? 8. So I start with 8. 8 to the 1/3 power is equal to... What does it mean to raise something to the 1/3 power? It's a cubed root. Very good. And so the cubed root of 8 is 2. So that's why, again, some of these, like, mathematically, you're like, oh, yeah, that makes sense. Yes, ma'am.
You have to write the 1 for number 10.
Exponent 1. On this type of problem, because it's just saying to convert, I would, so that way I know that you know where it goes. But in a mathematical statement, would you have to write the 1? No. But if it's saying convert, I probably would. I feel like, though, the ones we made you convert, we put, like, X's and stuff in there. But I think this is just kind of trying to make your brain warm up. All right, try these. Watch out for the ones that the base is not written in. You might want to write them in to help you, like number 14. What's your base? 10. No shame in writing that in. Number 15, what's your base? E. That would help me to write it in like that. And then I can go from there. So finish those, and then we can take a little break, and then we'll do inverses. Told you pretty quick. So as you're finishing these, again, we're not solving anything. Some of the ones, like the first 3, mathematically make sense. Let's talk about 12 for a second. Again, I'm assuming you got the conversion part correct, which is good because that's the main idea. But just a reminder, okay, what happens, so when you have a fractional exponent, because this will kind of come back like in the future. When you have a fractional exponent, that is the same thing as taking a type of root. This would be a cubed root. 1/2 would be a square root. 1/4 would be a fourth root. And that's why I just still get a whole number here. What happens when you have a negative exponent? Like, why is this true? 4 to the negative 2.
1/4 squared.
Because you take if there's a negative exponent, that base goes to the other side of the fraction, which in this case, 4 is in the top. So it becomes 1/4 to the positive 2, which is 1/16. Knowing those exponent rules and how those work, when you get to evaluating, again, it's Unit 12. I'm not going to be here. But when you get to that, like being well-versed in like what fractional exponents versus negative exponents do will kind of help you be able to reason through that if you didn't have a calculator and evaluate those that way. But then the bottom 3, those were kind of, you could figure out what 3 to the 30th power is. I don't even know if that would fit in your calculator. I can try it. But these, you wouldn't really be able to solve anything else there. But that's converting. Can we do that on our test? Okay. All right, let's take a little break, and then we'll do inverses, which is very similar. But we'll take inverses. Here we go. So this will be the second part of, again, this test topic. It's called, I think I called it like converting and inverses. So converting we just did. We all agree, super easy. Not going to be partial credit on that. Finding inverses is going to be a little bit more involved, so there will be some partial credit for this. But I think we've done inverses 3 times now, calculating them algebraically. So we wrote out the steps for you. We're going to go exponential to log, and then we're going to do the reverse as well. But they're really similar steps. So the first thing that you want to do anytime you find an inverse is you switch your x and y variables. But then you have to get either the exponential portion on this page or the log portion isolated, okay? So you're going to be moving some stuff around potentially. Then you're going to switch forms, and then you're going to isolate again. So again, there's more algebra steps in this. Still not really calculation because we're going to have 2 different variables in there. But if I look at number 18, we start off pretty basic, and then they get a little bit more challenging as you work through the page. First of all, what is f of x the same thing as? That's the same thing as y. So if you want to write over that on all of these, feel free. Okay? So I start with just swapping out those variables. So this is going to say x is equal to 3 to the y plus 4. Now, you really got to pay close attention to like what's in the exponent and what is not. Because, again, your step 2 is to get the exponential part all by itself. So that means this plus 4 needs to go to the other side so that I can get, this is my only exponential part right here. So how do I move a plus 4? Subtract 4. So you may have a few steps at the beginning just to get that exponential part by itself. And your exponential part could be like more complex. It just depends on the problem. So now I have x minus 4 is equal to 3 to the y. Now, my goal is to isolate y. And so to get y, remember what I kind of said about levels, to get y out of that exponent spot, I'm going to take a log. Okay, I'm going to convert to log form. Now, you're still doing what we did last class, What's a little bit different about inverses is typically the way they're set up. Your base is going to be on the right side, where like the whole last page, our base was on the left side. So your arrows are going to go like this, which is a little bit different, but it's still the same thing, okay? So the base of our exponential is 3, so what's going to be the base of our log? 3 as well. And again, I already drew my arrows. So log base 3 of, what's going to be the argument of my log? X minus 4, and then that's going to equal y. And once you get y all by itself, you're done. But to finish this, you need to make sure you write it in this inverse notation. So I would really put as my actual answer, f inverse x is equal to log base 3 of x minus 4. Now, this was a really basic one, so there wasn't a whole lot more to do as far as isolating goes. They will get more involved, and we'll work some of those, but this is kind of what I'm looking for. I also want your arguments to always be wrapped in parentheses, especially if there's like stuff you have to do after you convert. You want to make sure that you keep those arguments in parentheses there, okay? Let's try 21, and then I'll have you guys try the rest. Okay, this one's just got a few more steps. So again, think about the exponential portion. I'm going to underline the exponential portion right here. 4 to the x minus 6 is my exponential portion. So first thing, I'm going to swap. Okay, x equals 3 times 4 to the y minus 6 plus 1. I guess I probably should have underlined this part, but whatever. That's what I need to get by itself, is 4 to the y minus 6. And then I'm going to undo that with a log. So what has to move? The 1 and the 3. Now, does the order matter that you move it? You should be nodding your head saying yes. Okay? The first thing we have to move is the 1 by subtracting. So that will take care of that. And then now I need to undo the 3. Now the 3 is multiplying times something. So what's the opposite of multiplying? Dividing. So you could write it as over 3. I don't always like to do that. How do I like to do it? What's dividing by 3 the same thing as multiplying by? 1/3. But what do you have to make sure you put around the x minus 1? Parentheses. Okay? I promise we've done this before. It's just been a long time. And then this is equal to 4 to the y minus 6. I think some of our other teachers are okay, or like their answer keys might just say over 3. I would be okay with that too, but that's just not usually how I write it. I'd rather write it like that. So I've got the exponential part by itself. That's the first thing. You've got to isolate that. So this is all base and exponent. That's all that's left. Now we have to undo it. So I'm going to switch to log form. So log, what's the base of my log going to be? Log base 4. Again, they're the same. Now, what's the argument going to be? 1/3 times x minus 1. And here's, careful with your parentheses. That's how they should look. There's got to be a big parentheses around the 1/3. And then the x minus 1 is also in parentheses. And then what's that equal to? Y minus 6. So are you finished? No, because now you have to get y by itself. So what are you going to end up doing with that minus 6? Adding. Now it's going to be added after the log. So that's why I really want the parentheses around your argument there. I'm going to go ahead and do my f inverse notation because there's only one step left, but it would look like this. Log base 4 of 1/3 x minus 1 plus 6. And that's my inverse. Okay? So this is obviously more steps than just doing a straight conversion, but it does involve converting as well as isolating from there. Okay? So try these other 3, and then we'll check them, and then we're going to do log to exponential. It's the same thing. It's just you start with a log, and then you switch back to exponential. So pretty similar. So try those 3 real quick. I haven't worked 19 yet, but I'll put that on my answer key on Canvas so you can check these last ones. Because again, they're a little bit tougher anyways. So if you can do the hard ones, the easy ones should be easy as well. Last thing is just, again, finding the inverse of a log. Okay, here's the other thing too, because sometimes, yeah. It's log base 3 of x minus 4. Oh, wait, I'm looking at the wrong one. Log base 6 of x minus 3. And x is the only thing in the argument. I'll go ahead and write the answer. I'll do the work, but it looks like this. F inverse x is and do you have to write F inverse x? Yes. If you don't write that, are you going to get points off? Yes, because that's not right. Here's the answer to this one. X and then minus 3 like that. Okay? This is 19. I'll put the work back in for my key on Canvas. Do what? Y inverse? That's okay. As long as you have an inverse sign, you have to denote. I think I prefer that because these will for sure be functions and everything. But as long as there's an inverse, that's what we really need. Okay? Again, think about if you start with an exponential, your inverse has to have log in it. There will always be someone on this test that starts with an exponential and ends with an exponential inverse. And that's like so wrong, okay? You have to actually end up with the inverse function. So on the next page, same steps, but what are you starting with? What are you starting with? Log. So what should you be ending with? An exponential. Okay, real quick. I'm going to change problem 26 slightly. I think it was a typo. I don't know. I want to change it. Where it says log of 2 times x minus 3, scribble out the 2 right there and put the 2 in front. 2 times log of x plus 3 minus 9. And you know what? Let's just go ahead and do that one. Okay? It's still the same idea. We're going to switch x and y at the front. And again, I told you to change this because I wanted you to change it. That's the only reason why. I think it was a typo. I don't know, but I want to change it. So this will be x equals 2 times log of y plus 3 minus 9. So again, back to the argument thing. I believe it should be like pretty obvious. If something is a part of the argument, they will put it in parentheses. So like you can see on number 25, x minus 4 is the argument. What's the argument on 24? It's just the x. So if there's more terms in the argument, kind of like this one and this one, we will put them in the parentheses for you, okay? So if there's no parentheses there, then I would just assume the first thing is the argument. So what's the argument on 27? Following that logic. 2x. Okay, if you're confused on that, you can come ask, okay? And I'll tell you, yes, it's the argument, or no, it's not. I think it should be fairly obvious on the test when it is and when it's not, but just FYI, okay? So step 1, switch x and y. We did that. Step number 2, isolate the log portion, which is just this guy, okay? Log of y plus 3. So what has to go on number 26? The 9 has to move over by adding, and then the 2 has to divide by 2 or multiply by 1/2, okay? And could you distribute in? Yes. Do you need to? No, okay? And so this is going to equal log of y plus 3. All right, we got the log by itself. Now we switch form. What's the base? Good. Don't forget that. Don't forget that. So this becomes 10 to the 1/2 times x plus 9. Now this is an exponent because you're switching to an exponential. 10 to the 1/2 times x plus 9 power. What's that going to equal? So what's going to be your inverse? 10 to the 1/2 times x plus 9. Then what? Is minus 3 going to be in the exponent? No. It's going to be on the outside, like that. So please make it easy for me to tell what's in the exponent and what is not. Okay? Make sure your exponents are written, you know, superscript. Make sure your log bases are written subscript. Not confusing like that. I don't think there's anything else. Be careful right here. Natural log. What's your base in natural log? E. So you're going to end up with this. Your F inverse X will be base E. E to the something, something, something. Okay? All right, so try, let's do, how about y'all do 27 and 28, again, because those are a little bit tougher. And then you can go to your homework. And I will get these all worked out for you.